Indy, what do you think happened in the bottle? Go ahead and put that in the chat for me. Chamel, what do you think happened in the bottle? Oh, you weren't here, you say, Nikel. Perfect. I'll show you again. So this is an air pump. It's an empty bottle. And let's see what happens when the air goes into the bottle. So again, we watched the air go in the bottle and it exploded the bottle. So tell me, what do you think happened for that air to make the bottle explode? So I'm hearing different words. I'm hearing words like pressure. I'm hearing words like compress. I'm hearing words like explode. Okay. So what happened in the bottle is a lot of different things we're going to be able to explain based off of what we learned today. Okay. So a lot of people are saying that it's filled with mass. Some people are saying that it's filled with pressure. Some people are saying that it's filled with particles. So we're going to take a look and see what these words actually mean, so that way we can better explain what's going on as we watch air in a bottle. Okay. Now I'm trying to show y'all for the third time. Perfect. Okay, so here are some words that I want us to be able to clarify, because these were a lot of different words that I saw that people were saying in the chat when they were trying to describe what was happening in the bottle. All right. So the first word that we're going to define is mass. Okay. So we talked a lot about mass, right? Our main question is, does air have mass, or does things have mass? And we're actually going to take a look at what the actual definition of mass is. Okay. So in your notebooks, I want you guys to go ahead and write down the definition of mass. And I would like for Christopher Ellis to read for us what the definition of mass is. Go ahead, Chris. Yeah, Chris, I do that a lot. I do realize that your mic doesn't work. No worries. How about, let's see someone's mic who does work. And I would definitely love a volunteer, so I don't have to go and cold call people. But if you want me to cold call, trust me, I'm about it. I'm seeing a lot of the same hands. Okay. All right, Logan, good. Logan, your mic might be out, bro. Yeah, it's not working right now. It's cool. No worries. That's fine. Hey, Dylan, go ahead and read for me what mass is. Go ahead and read that definition for me. You gotta mute yourself, buddy. Yeah, you're still muted, sir. Oh man, y'all, I don't know if y'all trying to get me with these non-working mics, or if we gotta update the mics. But like, a lot of people can't respond right now. Okay. How about Isaiah? Go ahead and read what mass is. Read that definition of mass for me, please.
Read the definition of mass?
Yes, sir.
Okay. The almost of matter in any object is full. I got it. Huh?
It's the amount of matter.
Is amount of matter in any object or sample.
So yeah, it's the amount of matter in an object or a sample.
I want all of them.
All right. So if you don't have that note already, mass is the amount of matter in an object or a sample. Okay. So the amount of matter. So we also have particle, right? So what is a particle? Who can tell me what a particle is? How about Miss Damari Wolin? Can you read for me what a particle is? Ooh, looks like I'm gonna have to call home for some people because it looks like. Oh, my bad, Damari. See, I don't even see your camera, so I'm gonna call you Mr. Damari. Looks like I'm gonna need to either call home because one of two things are happening. Either our mics don't work, so we need to call home so y'all can get some new computers, or two, we're not participating. Okay, so I really, really hope it's not the latter. Hopefully, it's maybe just the mic isn't working, but a lot of us, I need some more participation. Okay, Miles, go ahead and read particle for me, please.
Particle, an atom or molecule, what everything is made of.
Thank you. So a particle is an atom or a molecule. It's basically what everything is made of. So everything around us, there are particles, right? So we're all made of particles. Everything is made of particles. Humans, technology, air, there's particles everywhere because they're all atoms, okay? Our next one is compress. So Michael, read for me a definition of compress.
Compress, to push particles closer together.
Thank you. So within particles, like I said, since particles are everywhere in the world, when we're compressing these particles, because particles can't shrink, they always stay the same size. What they do is they just move closer together. So that's how you compress things, or it's called pushing particles closer together. And then our last one, air pressure. Can I get a volunteer for air pressure? My other than Michael, who just read. Go ahead, Kendall.
You want me to do air pressure?
Mm-hmm.
Or you want me to read it?
Yes, sir.
The force extert on the surface by the mass of the air above. It also called the atmospheric. Did I say it right?
Mm-hmm.
Atmospheric pressure.
Perfect, right? So the force that on a surface, or that's exerted on a surface, basically the force that's pushed on a surface by the mass of air above, okay? And that's also called atmospheric pressure, which we're going to get a little bit more into when we come back from break. But air pressure is kind of the introduction for how we're going to learn the rest of the different pressure terms, okay? So if you don't have these in your notes, please put these in your notes right now. Again, mass is the amount of matter in an object or a sample. A particle is the atom or a molecule or what everything is made of. To compress is to push these particles closer together, and air pressure is the force exerted by a surface by mass of air above, okay? So I'm gonna give you about 10 more seconds to write these down. And then we're actually gonna put these vocabulary words into practice, all right? When everyone's good, can you go ahead and put done so I know that I can move on? Actually, no, I'm going to give you about 20 more seconds. Thank you, Ms. Dorsey. Got about 10 seconds left. 5, 4, 3, 2, 1, and we are going to move on. Don't worry, Logan, we'll go back to it. Perfect. So we're going to actually take a look at what happens when you are compressing particles and when you are expanding these particles as well, okay? So I'm going to stop share real quick. Okay. So if you take a look here, you can see that there are molecules, right, or particles. These are all gas particles or air particles. So we know that air is made up of gas, right, because it is made of nitrogen and oxygen, right? So nitrogen and oxygen are both different, and variable gases. Those are all gases which make up air. So air is then made up of gas, correct? So we're looking at these gas molecules, and they're moving around inside the syringe because there's air inside the syringe. Make sure we're staying muted, please. Thank you. So I'm going to show you, these are what air molecules look like when they're not trapped in something and they're moving all around, right? And this is what air molecules look like when they're trapped inside the syringe. So you see how they're moving slowly and freely in the syringe because there's not a lot of pressure. It's all like it's pressed up. It has more space to move. Now, I want you to take a look at and put in the chat, what do you notice as I begin to push the syringe down? What do you notice as the syringe is pushed down? What happens to the air molecules? Go ahead and put that in the chat. What happens to the air molecule? So I'm getting Logan saying that they're moving a little faster. They're also getting closer together. Trayshawn says the particles look like they're squeezing. All right, so based off of the vocabulary words we just used, right, what do you think is happening right now to these air particles? And it looks like Malaysia has used the word in there. What do you think? Thank you, Nishida. Exactly. So what's happening right now is we're compressing the air particles down. We're compressing them down. And when we compress them, we're increasing the air pressure. All right? So if you look at the syringe, at the bottom of the syringe is capped off. So there's nowhere for the air to go. So when we press the syringe down or press the plunger down, we're trapping the air inside of a very small space, which forces the molecules to bounce around faster because there's higher pressure, right? So when you let it up, there's less pressure, right? So with less pressure, the molecules are moving much slower, they're moving a lot freer, and they have more space because they're expanding, right? So when you compress, it shrinks and moves faster because it's high pressure. When you pull the plunger out, it expands and it moves freer because there's less pressure, okay? So now that we talked about that, I want us to be able to stamp a few things, okay? So the first thing, when you push the plunger, the air is forced into a smaller space. We say the air is compressed, okay? So when it's pressed in a smaller space, we say the air is compressed, which means the same amount of air is still in the syringe when it's compressed. So you notice that there's not that there becomes less air particles or there's more air particles when you pull it out or less when you push it down. It's the same amount of air particles, they're just closer together, okay? Then we also have that compressed air pushes back with a force equal to the force compressing it, right? So when you saw that when we pushed the air down, because the syringe was closed, the particles are bouncing themselves back up. So that's why if I let it go, it slowly pushed the plunger back because it was using pressure, high pressure, to push it back up. But then when it got to the top, it didn't go back down because it was low pressure. So the important thing to remember that is if you increase the volume inside the syringe, basically if you pull the syringe up, you are increasing the space by the gas. So you expand the gas. So when gas expands, there's less pressure. So that's what we were talking about, right? So when you pull it up and there was less space, or there was more space, there was less pressure because they weren't moving as fast because they weren't as tight. They had more space to move everywhere. And then the last thing is that, So the last thing is that when you push the plunger back and the pressure from the out of the syringe, it moves until the pressure inside and outside is equal, right? So it always wants to go back to an equal pressure. So the less